While computing has reached new heights due to many breakthroughs, there are many tasks affecting human lives that the current crop of computers cannot do. For example, scientists battling climate change and chemists in the laboratory often need more computational resources than what their computers offer. However, a new form of computing known as quantum computing is here to save the day. With these quantum computers finally hitting the market, you may be wondering, just what are quantum computers? What do they offer? And how do they affect you personally? If all the computers in the world as we know them were to vanish today, what would happen? Absolute chaos would ensue, as people's lives would be turned upside down. Even the Tesla car would suddenly become a dumb automobile with no in-car entertainment or autopilot. But more alarmingly, we will return to the days of the human computer. Yes, you heard that right. There was a time humans acted like computers. In fact, until the middle of the 20th century, computers were humans who performed calculations. You can see this in older books and numerous printed reference works. If your work required you to make some complex calculations, you would head to one of the reckoning centers. In these calculation halls, human computers worked with mechanical desk calculating machines. This was often the work of women. Thankfully, nobody is taking our modern computers away. They will only be superseded by a new type of computer just hitting the market, the quantum computer. While the name may sound exotic, quantum computers are not so hard to define. They are simply machines that use the properties of quantum physics to store data and perform computations. They perform tasks just like the classic computer you find everywhere, from your smartphone to your smartwatch. However, there are differences. These differences are what make quantum computers as powerful as they are. Classic computers encode information in binary bits that can either be zeros or ones. However, when it comes to quantum computers, you are talking about the qubit or quantum bit, which is the basic unit of memory. But what are qubits like? They're created using physical systems like the spin of an electron or the orientation of a photon. These systems can be in many different arrangements all at once, a property known as quantum superposition. You can even link qubits together using a process called quantum entanglement. The result is that a series of qubits can represent different things simultaneously. You will hear more about quantum entanglement later in this video. For instance, 8 bits is enough for a classical computer to represent any number between 0 and 255. But 8 qubits is enough for a quantum computer to represent every number between 0 and 255 simultaneously. But why are quantum computers faster than traditional computers? We will illustrate with an example to make it simple. Your average supercomputer might excel at difficult tasks like sorting through a huge database of protein sequences. However, one weakness is that when it comes to seeing the subtle patterns in the data that scientists use to determine how those proteins behave, the supercomputer falters. Why is protein even worth studying? Proteins are long strings of amino acids that become useful biological machines when they fold into complex shapes. So understanding how proteins will fold has many implications for biology and medicine. A classical supercomputer might try to fold a protein with brute force, relying on its many processes to check every possible way the chemical chain might bend before arriving at an answer. The problem comes when the protein sequences get longer and more complex, and your super expensive supercomputer starts to stall. Just imagine the enormous task. A chain of 100 amino acids could theoretically fold in any one of many trillions of ways. There is no classical computer with the working memory to handle all the possible combinations of individual folds. Quantum algorithms take a new approach to these sorts of complex problems by creating multi-dimensional spaces where the patterns linking individual data points emerge. So using our protein folding problem, that pattern might be the combination of folds requiring the least energy to produce. That combination of folds is the solution to the problem. Classical computers can't create these computational spaces, so they cannot find these patterns. The thing about quantum computers is that they are actually built for solving complex problems. Quantum algorithms solve complex problems by creating multi-dimensional spaces where the patterns linking individual data points emerge. Now, you would expect a machine capable of a mind-bending amount of calculation to consume lots of energy, but that is not the case with quantum computers. They are actually smaller and require less energy. However, the sizes here are relative because quantum hardware made by IBM could be the size of a car, with most of its space taken up by the cooling system required to maintain the superconducting processor at ultra-cold operational temperature. And far from the rudimentary quantum computers, the ones hitting the market very soon uses what is known as qubit entanglement to increase their computation power linearly. This is how it breaks down. Back in his time, the renowned Albert Einstein theorized that quantum particles would form correlations with each other, where the quantum state of one particle, such as the direction of its spin, could be determined from the state of another particle, even when they are far apart. Einstein called it spooky action at a distance and decided there must have been something wrong with quantum mechanics, but there wasn't. Experiments later showed that such correlations exist in nature and are at the heart of quantum mechanics. Entanglement is at the heart of quantum computers too, it's what makes them so very powerful. Entanglement is used as a computational multiplier for qubits. So what problems are scientists trying to solve with the new quantum computer? Foremost is global warming. Global warming is the worst that can happen to the planet caused by humans. However, quantum computers are the latest weapon in this fight to save the environment. To tackle global warming, we need to understand in complete detail the atomic level forces at play when molecules bond with other molecules or when they split. This knowledge could provide the means to invent new processes and materials that could be massively beneficial. The problem is that today's classical computers, including the largest and fastest supercomputers, simply do not have the ability to simulate atomic-level quantum interactions. Even with Moore's law, they would not reach that capability in 1,000 years. Quantum computing could have this ability within the next decade, as it uses quantum states of atoms to simulate the quantum forces of nature. Quantum computers will feature heavily in the battery evolution. Batteries have become very important as the world tries to shift away from fossil-based fuels. However, battery R&D relies on long cycles of experimentation and computational simulation. But with quantum computing, scientists gain the ability to simulate every element of the battery chemistry in a virtual experiment at the atomic level. Variables such as electrode materials, electrolyte formulas, binders, and separators can be manipulated and analyzed in virtual experiments to find the combination that will enable a breakthrough in energy density. Quantum computers will affect the food on your table too. This is because they find a role in fertilizer production, and it's a noble role indeed. Fertilizers containing nitrogen use catalysts that gobble up 3 to 5% of the world's natural gas. They cost nearly $300 billion a year and account for 2% of annual worldwide CO2 emissions. Nature creates nitrates for free and with no emissions, but scientists are now focusing on how to understand and emulate these processes, and this is where quantum computing comes in. Quantum computers will support the creation of new catalysts needed to make energy-efficient fertilizers and significantly cut carbon emissions. According to Boston Consulting's R&D initiative on quantum computing and technology, conventional computers would take over 800,000 years to model the molecules to replace existing chemicals. In contrast, a quantum computer would require just 1 day. Quantum computers will also help fight global warming by helping to develop carbon capture and storage technologies. It will help us discover new techniques for carbon capture which will improve our ability to pull carbon out of the air. Currently, there are no cheap and easily obtainable catalysts for capturing carbon because they are usually precious metals. This captured CO2 could then be used to produce metals, plastics, and concrete. Total is already using quantum computing in conjunction with Cambridge Quantum Computing to enhance materials for CO2 capture. Hydrogen is one of the cleanest fuels because it only produces water. However, producing hydrogen affordably is a problem because the process is mostly between 70 and 80% efficient. Most of the problems come from how complex water is in the liquid state. But quantum computers can help in the development of new hydrogen production methods that are more efficient. They will help in the simulation of the electrolysis process. Let's hear what you think of the quantum computer in the comments section below.